Welcome back to Blender Daily. In today's video, I want to demonstrate the techniques necessary to create cool face tracking effects with Blender. Let's get started. The very first step is of course to record the footage. I highly recommend you to paint a few high contrast points onto your face in order to make the motion tracking as easy as possible. We are going to mask them out later on anyway, so they won't be visible in the final render. Alternatively, you can also just try to track natural feature points in the face. This is a lot harder though, and you have to expect higher solve errors. Also avoid changing facial expressions during the shot, as this would distort the markers and make it impossible to track. Once the footage is ready, we can open up a new scene in Blender. Create a new motion tracking workspace and load in our recording. Let's also adjust the frame rate and resolution to match with our clip. In the motion tracking window, set the scene frames and click on Prefetch to load the clip into memory. In the Track tab, then go to Objects and create a new one for the face. For this clip, I want the tracker to take a look at the location, rotation and scale of my points. For better results, I also enable Normalize and change the match from keyframe to previous frame. Now to actually place the trackers, hold down Ctrl and left click on the markers. You might need to further adjust them, which you can do with the shortcuts G to move, R to rotate and S to scale. Once all of them are in place, make sure they are selected and start tracking forwards. Blender now follows the movement of them throughout the shot. And don't worry if some of them don't stay on all the way through. If that happens, just go to the last frame before they got lost, press Alt S to show the search area, adjust the size of it and try to continue tracking from here. This usually solves the problem. Once we have at least 8 active trackers on each frame, we are ready to solve the object movement. Before that, however, there is one last thing we need to set up, which are the keyframes A and B. Here we simply need to input 2 frames of our clip, between which the object, in this case my face, is moving a lot. In this instance, I decided to go with frame 1 and 108. After that, simply click on the Solve Object Motion button, and Blender will calculate the movement of my head in 3D space. It takes a few seconds to complete, and afterwards you can see an estimated solve error in the top right corner. In this example, my trackers were 1 pixel off on average. Since this is a 4K clip, a solve error of just 1 pixel is totally fine. Now let's take a look at the result in the 3D viewport. First I positioned and rotated the camera to roughly match the way I recorded my footage. Then add a camera solver constraint to it, so that Blender actually uses this camera as the base for the object track. Then just open the overlay settings and enable motion tracking. This now displays all our tracking markers in 3D space. And when we play the timeline, you can even see that the face is moving around, exactly as it should. In the camera properties, let's also set up the movie clip as our background, in order to see the results even clearer. For our effect, we also need a 3D model of a head that matches my proportions. Manually doing this would be extremely difficult and take a lot of time. That's why I made use of the FaceBuilder Add-on by Keen Tools. I put a link to this plugin into the video description. It is a paid product, but you have the option to get a 30-day free trial without any restrictions. The add-on can then be found in the side panel in the 3D viewport. All we need to generate a matching model is a single image of my face. I just use one of the frames from the clip for this. Once the image is imported, you can simply drag feature points of the mesh to the face and it will adjust itself in real time to match the proportions. It takes no more than a few minutes to achieve good looking results with this awesome plugin. After the face is aligned, go to the Texture tab. Enable autofill and then click on Create Texture. Everything else can be left on the default settings and it will generate the texture for the face based on the input image. Next, let's roughly align the head model with the tracking points. Then add an object solver constraint to it, select the face as the target object, choose the camera, and don't forget to click on Set Inverse. Now the head should be following along with the tracked face when we scrub through the timeline. Now that this is set up, let's refine the placement of the head to match with the footage as well as possible. The texture on our head model really helps, as we can try to match the red dots with the tracking points in 3D space. Just rotate, scale and move the head around until it matches up. Now it is finally time to actually create a hole in the head. Let's bring in a cube and place it exactly where the hole should be. Also give it an object solver constraint to make sure it follows along with the head model. To avoid the cube from covering the face, let's change the viewport display mode to bounce. To create the actual cut, we are going to use the Boolean modifier. Change it from exact to fast and select the cube as the object. It is now cutting into the mesh, however it is not really doing what we want. To fix this, also add in a solidify modifier and bring it on top of the boolean. Now the hole is looking a lot better. In case you get some weird shading issues, simply enable auto smooth to quickly fix it. We are actually going to apply the modifiers, so make sure you are happy with the setup before we move on. I'm also going to save a copy of the object to a disabled backup collection, just in case I mess up and need to go back. With the modifiers applied, we are now ready to shade the head. We don't need the texture from the FaceBuilder add-on anymore, so let's just remove it. Then create two new materials, one for the inside and one for the outside of the head. Tab into edit mode and apply the parts of the mesh to the corresponding materials. The rim around the hole should have the inside material. For the outside material, we are using a holdout shader, which makes everything behind it transparent, so we only see the inside of the head. Don't worry about the issues around the ears, we are going to deal with them in just a moment. For the inside of the head, I used the free PBR material from texturecan.com. The link to it is in the video description. Instead of the UV map, I used object coordinates though. To avoid weird stretching issues, simply change the projection of the image textures to box and slightly increase the blend value. This already looks pretty cool, but we still have the issues around the ears. To get rid of them, I simply extruded some edges in front of them to hide the mess from the camera. Then just apply the holdout material to it and everything behind it becomes invisible. For the render, I decided to use Eevee. To improve the result, enable ambient occlusion and screen space reflections. In order to bring back the footage in the background and make the holdout shader work, we also need to turn on transparency. For the lighting, I simply brought in an HDRI from polyhaven.com that roughly matched the conditions in my room. Then let's also enable motion blur for some extra realism, switch to the rendering tab and press F12 to see what this currently looks like. What we now get is just a hole in the head without the background footage. To bring this in, we need to combine the two plates in the compositor. Here I create my usual setup with the compositing node editor on the left and an image editor with the viewer node loaded in on the right. Then just combine the render layer with the movie clip using an alpha over node. Whenever we are using an image or a movie clip in the compositor, we also need to bring in a scale node set to render size to match it up with our render layer. Now this looks fine, but I promised you in the beginning that we are going to remove the red tracking markers from the face. So let's open up a masking workspace. Draw a mask around the points you want to remove. Then select all the vertices, shift click on the tracker and press Ctrl P to parent the mask to the tracker. When you now scrub through the clip, you can see that the mask follows along nicely, which is extremely helpful. So let's do this with all the other points as well that have to be removed. With this mask ready, we can go back into the compositor where we are going to use the mask node. Load in the one we just created. Then also make it a bit softer with a blur node. Now to actually remove the markers, bring in another blur node and plug the movie clip into it. Use the mix node to combine the two outputs and use our mask as the mix factor. Then just increase the blur radius and the trackers will magically disappear. Here is the version before and after. Back in the Render tab, change the output format to FFmpeg video and choose the MP4 preset. I like to use the perceptually lossless quality for the render. Also, don't forget to set an output folder. Now the only thing left to do is to click on Render Animation. Is your computer too slow to work with Blender? Don't worry, the sponsor of this episode has the solution for you. Renderro provides high-performance cloud computers for a very fair price. This means that you can access really powerful machines by connecting to their servers and create your 3D art directly on your personal Renderro desktop. I've already used it for some of my projects and I'm really happy with their service. I highly recommend you to give it a try if you feel like your current hardware is holding you back. For more information, visit renderro.com. That's it for this tutorial. Thank you very much for watching. I hope you found it interesting, and if you have any open questions, feel free to leave them in the comments. I am Nick from Blender Daily. See you in the next one.